Okay, so let's go over some practice problems. So the first one says arc cosine. So before you do anything else, you should draw your hot lava. Cosine's hot lava is on the bottom. And then you have to decide between the remaining two quadrants. Well, since this is negative, we know cosine is negative in the second quadrant. So we want to use our unit circle and find the negative root 2 over 2 that's in the second quadrant. The other trick is that when we measure it, we have to start from right here. So we want to start right here and get to this place right here where cosine has a negative root 2 over 2. Remember, cosine is the x value. So when you look on your circle, the answer to this problem is 3 pi over 4. This angle right here is called 3 pi over 4. And the ordered pair right here is negative root 2 over 2, root 2 over 2. And that's that x value right there that we were looking for. So 3 pi over 4 is our answer number 1. I'm going to keep doing the odds. Number 3, it says arc cosine. Again, arc cosine's hot lava is on the bottom. It's negative again, so we know we're going to be somewhere over here. We want to start here and get to where cosine is a negative 1. Well, that happens all the way right here when you look in your unit circle. This angle here is called a pi. The directions say to give your answer in radians, but we don't always have to give it in radians. So maybe on your test or somewhere else it asks for the answer in degrees. Pi is equal to 180 degrees. And with number 1, 3 pi over 4 on the unit circle is equal to 135 degrees. We're on a roll. Number 5 is also a cosine. So number 5 says, I'm on a roll with cosines and negatives. Cosine's hot lava by now. Hope you know it's on the bottom. The negative makes me want to be in this quadrant. I want to start here and get to that red circle somehow, but I want to land on the place where cosine is negative 3 pi over 2. So if you look at your unit circle, it's not quite all the way to the x-axis. This angle is called 5 pi over 6, which in degrees is 150 degrees, but this paper said radians, so 5 pi over 6. The next one's a little bit trickier. Secant is cosine's friend, or cosine's reciprocal. So instead of thinking about secant, we can write arc cosine, but when we do that, we have to flip this as well. So this becomes a negative 1 over root 2. Well, this thing right here is not rationalized. So we rationalize it by multiplying by a root 2 over root 2. So this statement is the same thing as saying arc cosine of negative root 2 over 2, which we did in problem number 1. Problem number 1 is that exact statement, so we know the answer is 3 pi over 4. But we can take any secant or cosecant, change it to its friend, cosine or sine. The only trick is to make sure that you flip or reciprocate that as well. The answer to this one is 3 pi over 4, 135 degrees. Sine of negative root 2 over 2. So sine's hot lava is different. Sine's hot lava is on the left. So if I want sine to be negative of the remaining two quadrants, it has to be in the fourth quadrant. And so I'm going to start here and I'm going to go down, which means I'm going to have a negative angle. I want to be at one of the 45 or the pi over 4s. This ordered pair here is root 2 over 2, negative root 2 over 2. But I can't go this way. Sorry, this green one, I can't go this way. Because if I do, I go through the restriction. I call it hot lava. You will burn and die if you go through the hot lava. That's bad, 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 bad. So we have to start right here and just go down. So instead of calling it 7 pi over 4, we're just going down 1 pi over 4. And when you go down 1 pi over 4, the answer is negative pi over 4. We could also call that negative 45 degrees. So the odds were done here. You can go ahead and pause the video and go through and do the evens. The evens are your homework grade. They are going to be due on Wednesday, like the top of this paper says. When you're done with that, come back and resume the video so you can watch the next group of questions. Okay, so on the next page, things change a little bit. Now I have what's called composition of functions. I have one function inside of the other. So what we're going to do is we're going to start with the blue on the inside. Cosine of pi. So I take my unit circle, I go to pi right here. The ordered pair here is -1, 0. Cosine is the x stuff, so this whole piece right here becomes a -1. So now I have arc cotangent of -1. So you start on the inside, you evaluate, and then you go to the outside. So now, cotangent hat lava is on the bottom. I want to be a negative, so I'm going to be in this quadrant. And we can just think for a second. When cotangent's -1, we can do arc tangent and flip the -1 over. But when you flip -1 over, it's still -1. So this happens at the 45s again. So I want to start here and get there. That angle is called 3 pi over 4, or you can write it as 135 degrees. Okay, so we're going to start with the next one. Again, we're going to start on the inside. So I start on the inside. I go to pi over 4. The ordered pair is positive root 2 over 2, positive root 2 over 2. Cosecant is sine's friend, so I want the y value. And so they're friends, but they're reciprocals. So cosecant of pi over 4 equals the reciprocal, so 2 over root 2. I'm not going to rationalize that yet. If I need to go back and rationalize it, I will, but maybe using this will be helpful. So let's just see if that's helpful. So now I'm going to go back here. I have my secant of this positive 2 over root 2. So remember, secant is cosine's friend, and if you do cosine or arc cosine, you have to flip or reciprocate with the number. So you have to make this a root 2 over 2. So cosine, arc cosine has hot lava on the bottom. It's positive, so I want to be in the first quadrant, and I want to start here and rotate some angle. Well, that angle is this one right here, like that. And that ordered pair right there is going to be root 2 over 2, root 2 over 2, which is the 45 degree angle, or pi over 4. So my answer to this problem is pi over 4, or 45 degrees. So go ahead and pause the video and try 12 and 14. When you're done, come back and unpause the video, and we're going to resume trying some new sets of problems. Okay, so now let's try 15 and 17. These ones are a little bit different because we're going to start on the inside again. But on the inside there, I don't have something that I know off the unit circle. I don't have a 1/4 that I wrote on my circle. So what we're going to do is what arc really means. The sign of the -1, the arc, it means make the angle exist. Maybe you can't name it like we were. You can't name it pi over 2 or pi over 3 or pi over 6. But I can make the angle exist. So I'm going to start by saying sine's hot lava is on the left. And this is positive. So I'm going to draw in the first quadrant. I'm going to draw a triangle in the first quadrant. And if you remember, sine is the y over the r. So my y value is 1 and my r value is 4. I can now do Pythagorean theorem. R squared equals x squared plus y squared, or a squared plus b squared equals c squared, whatever letters you want to use. My 4 is my r value. I'm solving for my x value, plus 1 squared. 16 equals x squared plus 1. I minus the 1 over. I get 15 equals x squared. I'm going to square root. You're going to be very careful. When you square root, remember there's a plus or minus out front. But because we're in the first quadrant, we know the x has to be the positive version. So x is positive root 15. Positive root 15. I can't name the angle, but the angle's right here. Its name is theta. So this whole blue thing is going to become theta. So the question now asks me, what is tangent of theta? Well, theta is that angle right there. And tangent's equal to the y over the x. So my y value is 1, and my x value is square root of 15. I can't leave it. You have to rationalize. Multiply by root 15 over root 15. So my answer is root 15 over 15. So tangent of whatever arcsine angle was is root 15 over 15. Okay, so we're going to use the same idea, and we're going to do the next one, number 17. We're going to start on the inside. It says arc cotangent, so cotangent's hot lava is on the bottom. The 1/4 is positive, so we're going to go in the first quadrant. These are the same numbers we had before, but they're a little bit different place. If you remember, cotangent is the x over the y. So I'm going to draw my triangle in the first quadrant. The x side is 1 and the y side is 4. X squared plus y squared equals r squared is going to give me my hypotenuse. So 1 squared plus 4 squared equals my r squared. So I'm going to get 1 plus 16 equals r squared. So 17 equals r squared. When you square the radius is never, ever, ever negative. So r equals the square root of 17. And again, we can't name the angle, but we can say, oh, the angle exists. It's right here. It's theta. So this whole inside piece becomes a theta. And now I'm left with cosine of theta. Cosine of theta is the x over the r. So if you go to your triangle, the x piece is 1. The r piece was square root of 17. So I get 1 over root 17, which we have to rationalize as root 17 over root 17. So our final answer is the square root of 17 all over 17. So you can go ahead and pause the video and you can try number 16 and 18 and then come back and I'll do 19 and then you can do number 20. Okay, number 19 is not much different than 15 and 17. So I'm going to start here on the inside. Cosine's hot lava is on the bottom. This x is positive, so I want to be in the first quadrant. I'm going to take this piece right here. This arc cosine of x is like saying x over 1. So remember, cosine is the x over the r. So the x side of my triangle is going to be called x, and the r side is going to be called 1. So then I do x squared plus y squared equals r squared. My x side is called x squared plus y squared equals 1 squared. So x squared plus y squared equals 1. I'm going to minus the x squared over so I can solve for the y piece because I don't know what y is called. I get y squared equals 1 minus x squared, and then I square root it. And because I'm in the first quadrant, I'm only going to take the positive root. So y equals 1, the square root of 1 minus x squared. You cannot break that radical apart. It is the square root of 1 minus x squared. So I've made the angle exist. It's right there. It's theta. So this whole thing becomes a theta, and I'm left with cosecant of theta. Cosecant is sine's friend, and sine is the y over the r. So cosecant is the r over the y. So that's going to get me 1 over the square root of 1 minus x squared. I can't leave it like that, so I'm going to multiply by the square root of 1 minus x squared over the square root of 1 minus x squared. My answer becomes the square root of 1 minus x squared on top, and on the bottom, those two roots are going to undo each other. It's like saying the square root of 1 minus x squared squared, and so the root and the square undo each other, and you're left with 1 minus x squared, and that is your final answer. So you're going to do the same thing for number 20.